right? So we did solve one question in the last class. I think so. I have asked to calculate the mass of lead. I think so. I have asked to calculate the mass of lead. Let me tell you. Let me tell you. Let me tell you. Let me tell you. Okay. Yes. So I told you this equation that was Pb2 plus 2 electron, and that forms Pb. Okay. Uh, okay. Then I have given you the current. Then I have given you the time. I have asked the mass. I have asked to calculate the mass. Okay. So let's do it again so that you would get a bit idea related to this. I was given you, I was, yes, that was 1.5 and the time was 20 minutes. Then I told you, you have to convert the minutes into seconds. Then you would be multiplying this 20 by 60. Then you would be getting 1200. Then you would be getting 1200 seconds, and you're supposed to calculate the mass of lead. Okay, what I told you that step number one, first of all, you are supposed to calculate the charge in coulombs. You are supposed to use this formula: Q is equal to IT. I is the current, T is the time, that is 1200 seconds. Then you would be calculating the charge in coulombs. Can you tell me the answer? Fast. We are short of time. Fast. Please use calculator. Fast. Your time is very important. 1800 coulombs. Good. This is 1800 coulombs. I told you this in the last class. And then I told you that, you know that 1 Faraday is equal to this much. This much. You know that 1 Faraday is equal to 1 Faraday is equal to this much, 96500 coulombs. Okay, 1 Faraday is equal to this much. But if I have this equation in which I have 2 moles of electron, if I have 2 moles of electron, if you can see this, 2 moles of electron I have. Okay, so I would be I would be writing just like that, 2 into F, that would be 2 into 96500. So what's the answer? Yes. 2 into 96500. It's 193,000. Am I right?
Yeah.
Coulombs per mole. Coulombs per mole. Coulombs per mole. Okay. Why it's coulombs per mole? I told you that it's the charge on 1 mole of electron. Remember, it's the charge on 1 mole of electron. So that's why I'm writing coulombs per mole. What if I have 2 moles of electron? So I would be multiplying this value by 2. Okay, it's mean that I'm giving you very important concept. It's mean that this much this much this much charge is required. This much charge is required to deposit according to the equation. See the equation. According to the equation, it's 1 mole of lead. It's 1 mole of lead. So to form 1 mole of lead, I need 2 electrons. So this much charge is needed to deposit. This much charge is needed to deposit 1 mole of lead. 1 mole of lead. Or I can write it down. This much charge is required to deposit 207 grams of lead. Now, if you're thinking, sir, what are you doing this? Basically, remember, 1 mole is equal to the mass of anything in grams. Hopefully, you know this. 1 mole of anything is equal to the mass of anything in grams. So just I did nothing. I just wrote the mole into the mass. Like this is the AR of lead. It's given in the question. But I have this much charge that I have calculated. I have this much charge that I have calculated. So if I have this much charge, so what would be the mass? This would be X. This would be X. So X would be equal to 193,000, 193,000, 193,000, no, 207 times 1800 into 193,000. Basically, I'm just going to cross multiply this just like that. Okay, then I need to find the value for X. So I would be rearranging this equation just like that. So hopefully you would be getting 1.93 grams of lead. Am I right? This is your answer. Am I right? This is your answer. Yes. Okay. Yes or no? Is that correct? Yes. आगे चलूं? आगे चलूं? Yes or no?
Yeah,
Jaldi.
it's correct.
Good. Okay. Now see this. Now see this. I'm going to send you another question. See question 5. See question 5. Question 5. Fast. I'm going to give you time. Fast. Check. So you guys are getting 5.44. So let me solve this. Okay, 5.44. Okay, Sahil. Let me solve. Okay, let me solve. Okay, okay. Just wait. Wait. Okay, so I'm going to just make the concept more clear. Obviously, these values are changed, but the whole things are same. Can you tell me what's the current and time? Can you tell me what's the current and time? Yes. Yes. Mm-hmm. What was the current? What was the current? Yes.
1.8.
And
And what was the time?
45 minutes.
So I would be multiplying this by 60. So what you were getting the answer?
45. 45.
45. Okay. Okay. 45? No. The time is 45 minutes. Not 35. It's 45 times 60. So what's the answer?
4860.
Okay, good. This is Coulomb. Okay. Then
48.
you know that silver, it's silver deposited. It's silver deposited. What's the equation for silver? What's the equation for silver? It's Ag positive. It's gaining 1 electron to form Ag, to form Ag. So 1 Faraday is equal to 96500 coulombs per mole. I'm not supposed to multiply this by 2 because this is not the case we did in the last question, because in the last question the equation had 2 electrons, but right now I have 2 electrons. Right now I have 1 electron, so I'm not supposed to multiply this equation. Okay, so 96500 coulombs needed to deposit 1 mole of Ag. And one mole of Ag is equal to 108 grams of Ag. Okay, if I have this much charge, what would be the mass? This would be X. Can you tell me an answer? Yes. Same answer you are getting?
5.44.
Okay, good. Okay, good. गुड हो गया, गुड हो गया, गुड हो गया, गुड हो गया जी, गुड हो गया. See the question number 6. See question number 6. This is related to the volume, not the mass. Just try, then I would be solving. I'm giving you only 2 minutes. Right now, I'm giving you only 2, not more than 2. Okay. Okay. So see this. I'm going to solve it. Calculate the volume of hydrogen produced. Calculate the volume of hydrogen produced at RTP when a concentrated aqueous solution of sulfuric acid is electrolyzed for 15 minutes using a current of 1.40 amperes. Okay. See this, how you would be doing the working for the volume, how you would be doing the working for the volume. Okay, first of all, again the same thing, you would be applying the formula Q is equal to IT. Again the same formula you would be applying, Q is equal to IT, right? Okay, in which you are given the current that is 1.40 amperes and the time is 15 minutes. You would be converting the time into the seconds, okay, minutes into the seconds. So I would be multiplying 50 by 60. Okay. Okay, so can you tell me an answer?
1260.
1260 seconds. Okay.
Coulombs.
In coulombs. Sorry, coulombs. They are in coulombs. Okay. In coulombs, right? And then obviously the equation for hydrogen is this. So ultimately I would be writing 2 Faraday. Again, you would be getting 193,000 coulombs. Again, you would be getting 193,000 coulombs. So this much charge is needed to deposit 1 mole of hydrogen gas, that is equal to 24 decimeter cube. That would be equal to 24 decimeter cube. Okay, that would be equal to 24 decimeter cube, right? So if I have this much charge, that is 1260 coulombs, what would be the volume? What would be the volume? Yes. Now you're supposed to cross multiply. It's very simple. Now you're supposed to cross multiply. It's very simple.
Uh, 0.16.
0.16 dmq. Hopefully you got it. How we do? Find out the volume. Same as the mass. Same as the mass. Okay. Now see this. Question number 7. It's the last question. Yes, question number 7. Okay, so in question 7, you can do all the things that would be same as I did in this question, question number 6. But the thing is that in this question, the equation would be different. Let me tell you equation. This is the equation for question number 7. So what would be the different? You would be multiplying this Faraday by 4, not 2. Everything would remain the same. Everything would remain the same. Everything would remain the same except this. That's it. It's very simple. Okay, hopefully you got. Okay, done.